area of our Gaussian surface. The Gaussian surface that we ended up drawing was a sphere. So the surface area of a sphere is 4 pi r squared. And it's equal to the charge enclosed divided by epsilon naught. And so for part 1, when the radius is larger than c, you can see that the charge enclosed is essentially the overall charges added up, right? The sum of the overall charges. And so what we have is we have a -3 charge plus a +2 charge. So that'll get us, so our electric field for part 1 is E is equal to, so again, the charge enclosed is the charge from the spherical shell, which is -3. So it'd be -3q plus 2q, because that's also enclosed, right? The insulator shell, divided by epsilon naught. And all I did was, to get E by itself, is I divided 4 pi r squared. So you got to divide 4 pi r squared. Oops, I should say r squared. R squared. So that, can you guys read that? I don't know if you can read that. Maybe I should write it larger. E is equal to, so it'd be -q over 4 pi r squared epsilon naught. Yeah, so that's for part 1, when the radius is larger than c. So now we need to do the same thing for part 2. So for part 2, I'm going to get rid of these electric charges. Oh, actually I should have. Okay, so for part 2, now we're looking for the radius r when it is inside the material, like let's say here, at this point here. And so now we can again use our Gauss's law. And so we have our Gaussian surface inside the shell. So essentially, it's going to be the same thing. It'll be electric field times the surface area of our, so now we have a sphere, right? This dotted line represents the sphere. The surface area of the sphere is equal to charge enclosed over epsilon naught. Well, what is the charge enclosed? Well, the charge enclosed is, remember, because of this +2q, there's -2q on the inside of this surface, of the inside surface of the outer shell. And so it's going to be E equals, charge enclosed is going to be -2q, but then we also inside have this, so plus 2q all over epsilon naught, and then 4 pi r squared, right? Because our radius is r. Well, if you notice, -2q plus 2q is equal to 0. 0 divided by anything is just going to give you 0. So our E field for part 2 is equal to 0. Okay, everyone got that? I hope so. I already see it now. Okay, whatever. Ah, man, long day. I hope this helps. Hopefully this helps everyone. That test, man, that test was something, right? Goodness gracious. Okay, so now for part 3, now we're thinking outside of this inner sphere, but inside. So same thing. We're going to use our Gaussian surface. So now, let's say a point here, and we want radius r. So let me draw, or actually let's do it here. And radius, this radius is r. So now, again, we have, we're going to draw our Gaussian surface, so our sphere around here. So now we have E times the surface area of our sphere, 4 pi r squared, is equal to the charged enclosed, which in this case is just 2q, right, over epsilon naught. And now remember, our surface area is 4 pi and its radius. So the radius here is, we just say r. So now for number 3, E is equal to 2q over 4 pi r squared epsilon naught.